Hello there. In today's video, we're going to go through skill 57. Remember, we're going through the pink packet that is in the pile by the door. So make sure you're on page 6. We're going to start with question 19. The Hot and Tasty coffee chain conducts a survey of its customers at its location at the Staten Island Ferry Terminal. After the survey is completed, the statistical consultant states that 70% of the customers who took the survey said the most important factor in choosing where to get their coffee is how fast they are served. Based on this result, hot and tasty coffee can infer that. Now, there was a problem with the survey they did. They only surveyed customers at that one location, and the people at that location answered heavily in favor of coffee being fast. So choice C is the answer. Most of the customers at the Staten Island Ferry Terminal care more about being served quickly. So we can't make judgments about this whole company or about any of their other locations because they only talk to one of their locations. Now, this is a ferry location. That means that it's a place where people are traveling and they need to be in a hurry. So this is a biased survey. We don't want to use this to make decisions about the rest of their chain, just specifically about the Staten Island location. Number 20, the results of simulating tossing a coin 10 times, recording the number of heads, and repeating this 50 times are shown in the graph below. So to explain what they did here, they tossed a coin 10 times, wrote down how many heads there were, and then did that study 50 more times. And they probably actually didn't toss the coins. They probably made a simulation do this, meaning they made a computer program that did it, or they found a way to simulate something being 50% of the time, like a random number generator or something. So they probably didn't actually do this study 50 times. There would have been 500 flips. They probably didn't do that. And each dot represents a single study and how many heads were found during that study. So you can see on my drawing here, these two lines here represent 95% of the data. 95% is a really important value when we talk about statistics, because when you do a survey or when you're collecting data about something, 95% of the data should fall really close to the average. And we'll talk in a minute about standard deviation, but most of the data should fall within 95% of the entire range of data. So 95% of 50 is 47.5. That means that 47.5 of these dots should fall between 1.5 and 8.5, which obviously we can't have halves, right? So most of the data should fall between these two lines that I drew here. And you can see that there was only one dot below that line and only 2 dots after that line, which works out to pretty much 95%. So anyway, now that I've explained that, let's go through the choices here. 5 heads occurred most often, which is consistent with theoretical probability. They want to know which statement is false, and that is absolutely true. When you flip a coin 10 times, the most common result should be 5 heads, 5 tails. Choice B was the actual answer here. When we got 8 heads, that's not unusual. Remember, I just said that most of the data should fall between these 2 dots. And that 8 is inside that window, so that's not unusual. So choice B is the false statement. Well, let's go through the other 2 statements. Of turning 3 heads or fewer occurred 28% of the time. So I circled here and I counted. There were 14 dots in that in the study that were 3 or fewer heads, and 14 out of 50 is 28%. So it's not C. And then choice D, 7 heads is not unusual, as it falls within the middle 95%. Well, that's true. I said that if it's between these 2 lines, then it's not unusual, and 95% of the data should be in that window. So D is not the answer, B was the answer. Alright, this is number 21. Abby is told that each day there is a 50% chance of rain. Which simulation can Abby perform to determine the likelihood of it raining for the next 7 days? Should she flip a coin 7 times, count how many heads, and then do this study 50 more times? Should she roll a die 7 times, count how many twos, and repeat the study 50 times? Should she roll a pair of dice, count the number of sevens, and then repeat that study 50 times? Or should she flip a coin 50 times and just count how many heads? Well, the answer is A. Flipping a coin has two outcomes, which is a 50-50 shot, right? Which is what she wants to simulate. And we don't want to just flip the coin 7 times and say, well, that's what's going to happen in the world of water. We want to do that multiple times because one experiment, one sample is not enough. If I want to simulate something, I need to simulate it happening a ton of times and then take the average of everything that's happened. Because flukes happen every now and then, but if you do it different times, the flukes will kind of average out, they'll kind of work out. So choice A is the answer here. Our next question, number 22, Mrs. Avada's statistics class wants to conduct a survey to see how students feel about changing the school's mascot name. Which plan is the best process for gathering an appropriate sample? When you're gathering a sample of data, you want to be unbiased about it. You don't want to go somewhere or do the survey in a manner that only talks to certain types of people. So choice A only talks to seniors. This representation is not fair. We want to talk to the whole school, not just seniors. And if you're a senior, you don't really care what's happening in the school. You'll leave in, right? So that's not a fair sample. Choice B says talk to every 10th student entering the art classes. If the school mascot represents everyone, you can't just talk to art students because not everyone takes art. There's a certain type of person that takes art. Just like there's a certain type of person that would, go to BOCES or major in stats or take extra gym classes, right? You want to make sure you talk to everyone, not just a specific type of person. We'll skip down to choice D. Choice D says only talk to the sports teams. Well, that's biased too, right? They're going to be wearing the mascot on their chest, and they're going to have an opinion about this, right? But we want this opinion to be representative of everyone, not just the athletes. So that's why the answer for this is letter C. Just talk to everyone that goes in the cafeteria, every 4th student. That's going to be unbiased because everyone's going to go in it. Most people are going to go in the cafeteria, right? And if you do every 4th person, then you don't have control over who you're talking to, right? It's just whoever happened to walk in at that moment. All right, number 23. Anne has a coin. She doesn't know if it's fair. So a fair coin would mean that, it really is truly a 50-50 shot of flipping heads or tails. There is, in this world, there is something called an unfair coin or a biased coin or a rigged coin. Or a loaded coin, and we're going to test to see if she has one of those. She flipped a coin 100 times and got 73 heads and 27 tails. Now that's a little peculiar to get 73 heads and 27 tails. You should get close to 50-50, right? Not exactly 50-50 every time. You should get close to it though. So she ran a computer sample of 200 samples of 100 fair coin flips. So she told the computer to flip 100 coins and record the results. And then she repeated that 199 more times. And each dot represents one of those studies, and it represents what percentage of the study resulted in a heads. So when you look at it, you can see that the most likely outcome was 50-50, right? And most of the dots are falling in this middle range, right? If we're not expecting exactly 50-50, we're probably expecting something close to it. Now in stats, when you do something like this, you should end up with something called normal distribution or a bell curve. And you can kind of see it here. The columns are stacking. The ones in the middle are taller and the ones on the outside are shorter. It should make a bell-shaped curve. And 68% of the data should be between these two lines. And 95% of the data should be between these two lines. That means the other 5%, the part that is not between these two lines, are those little outliers that happen outside those lines. Where do you get those numbers? Well, I explained down here. 68, 95, those are always the standard percentages that you deal with when you talk about normal distribution. And how you determine where those lines are drawn? You're going to use the average from the study plus or minus the standard deviation. SD is the standard deviation. They told us the standard deviation in this problem is 0.05, and they told us the mean is 0.497. So if you do this math problem, it'll give you a range that 68% of the data should fall. So I did this math problem on my calculator. I did it once with a plus and got that. And I did it once with a minus and I got that. And that means that 68% of the dots should be between 0.447 and 0.547. And I drew those as lines on the graph just to show. And just a simple eye test shows that, yeah, about 68% of the data falls in that window. 95% is the same process, but now instead of doing the average plus the standard deviation or minus the standard deviation, it's the average plus or minus double the standard deviation. So remember, I said SD is standard deviation. What is standard deviation? Standard deviation is the average distance all of the data is from the average. So they take all the outcomes and they see what's the average distance from the average. So if the average in this question was 0.5, that means that on average, most of the data we collected is 0.05 away from the average, which means most of the data, when we sum it all up using average, is within 5/100ths of the actual average. Okay? So back to the 95%. 95% of the dots should be between 0.397 and 0.597, and I've drawn those here. So anyway, this is a pretty standard bell curve. It's not a perfect bell curve. It's not symmetrical, but it's pretty close. And when you do studies, most of the time, normal distribution is expected. So now that we've explained all that, what does that mean in the context of this problem? A and B both talk about what's going to happen in the future, and we can't predict that, right? 73 of the computers next to 100 coin flips will be heads. We can't predict that. If you look at the chart, that never happened. There was not a single dot, there was not a single outcome of the study where 73% of the results were heads. So we shouldn't predict that. Same with choice B. We can't predict this that 50 of the next 100 coin flips will be heads. You can't predict what a coin is going to do. Even though it is the most likely outcome, we can't predict that. So now we have to answer, is her coin fair or not? If her coin was fair, it would definitely be between these two lines in the 68% range, and it would probably be in the 95% range. If it's outside these two lines where my fingers are, if it's outside those, then it's probably not a fair coin, because that's an unlikely result that only happens 5% of the time. So 73 heads never happened in all of the 200 simulations we did. So that's probably an indication that her coin is not fair. All right, next one's question 24. The operator of a local mall wants to find how many of the mall's employees make purchases in the food court when they are working. She hopes to use these data to increase the rent and attract new food vendors. In total, there are 1,023 employees who work at the mall. The best method to obtain a random sample of the employees would be to survey. Now, she said she wants to do a sample. That means don't talk to everyone, only talk to a small selection of everyone. So a sample means let's do a small group, and it also means let's be fair about it. Let's not talk to a biased sample, let's talk to a fair sample. If we only talk to the 170 employees at each of the larger stores, that's unfair that we're only talking to the large stores. We don't want to do that. 50% of the 90 employees of the food court. Well, of course, the people that work in the food court have an opinion on this. We can't talk to just them. Some of them might say, we don't want this because we don't want the competitors to come in. Or they might say, we don't want this because we don't want to be busier. Or they might say, yeah, we do want it because we want more money. Every employee, that's not a sample. We can't do that. That's going to be logistically a nightmare. So the answer to this is D. Every 30th employee entering each mall entrance for 1 week. So it's not biased by standing by one of the entrances. It's not biased by standing in a specific store. And it's not biased by picking a specific day. Maybe there's someone who wants to go to the food court but only works on Tuesdays. So 24 is choice D. 25, a random sample of 100 people that would best estimate the proportion of all registered voters in a district who support Improvements to the high school football field should be drawn from registered voters in the district at hey. Don't go to a football game. Of course they're going to support the football field. Don't go to a school fundraiser because people that go to fundraisers want to support the school. And don't go to a high school band concert because, again, the only people there are there because they want to support the school. You have to go somewhere that represents everyone. And people that vote in a district vote are going to be the general population, people that live in the community and maybe don't have kids there and maybe have no reason to step foot in the school. So a supermarket is going to be the least biased, the most fair, the best sample for this. And then the last question here, this question's huge, it takes up the whole page. We have a spinner with 6 sides and each section is divided equally. For Miles to win, the spinner must land on the number 6. Miles spun the spinner 10 times and never got a 6. Miles thinks the spinner is unfair. So at home, his dad ran 100 simulations of spinning the spinner 10 times, assuming the probability of winning each spin is 1 out of 6. So here again, we have a sort of bell-shaped curve here. They told us the average outcome is 0.157. Now, a 6 should come up 1 out of 6 times, which is 0.16. So the average is really, really close. The average of our study is really close to what we expect to have happen here. And just like the question from before, we're going to see where 95% of the samples fall. Because if Miles' result is outside that 95%, then that means that Miles was probably being treated unfairly here with the spinner. So remember, to find 95%, you do the average, plus or minus, double the standard deviation. So I did the average minus double the standard deviation and got that number, which just happens to be negative. And I did that number plus the mean plus double the standard deviation, and I got that number. And I drew those numbers as lines here. And that means that 95% of the study, whenever they do a simulation, 95% of the time, our result should be within these dots. And it's true, like, it's almost perfect, right? There's a couple out here, but most of the data falls within that 95%. So what really this means is, how likely is it that 10 spins would never give you a 6? And look at our study here. Look at all the times in the simulation that a 6 didn't come up in 10 spins. It happened 20 times out of a study of 100 samples. And we already agreed that anything in this range is fair game. It's probably going to happen. It's reasonable to expect it to happen. So the fact that it happened 20 times in our study, and it's in the 95% window, means that Miles wasn't scammed here. Miles just got unlucky, right? And in fact, it's not really unlucky. It's just a quick common outcome, right? So its choice explains that. Choice C says that. The spinner was likely not unfair. I don't like all those words there. The spinner was fair, is what it should say. The spinner was likely not unfair, since the number 6 failed to occur in about 20% of the simulations. Yeah, we got both 6s 20% of the time. That's reasonable, and that's not unfair. If the thing we were looking for was way out here, maybe we should say that it's unfair. But right now, it's a fair sample. It's a fair study. Miles just got a result you didn't like. So, thank you for watching. That's all for today. Have a good day.